Any questions from last time? I see the one over there. The option is changed. So tell me, who's gonna start? Any keywords from last time?
Hyundai Tucson versus
Types of virtualization.
I thought
Types
it was
of
mine.
virtualization, right?
Type
Yeah.
1 virtualization.
Type 1, type 2. What are they? Yeah. Can anyone tell me what's the difference between type 1 and type 2? Just an example too. When we say OS level or hosted virtualization, is that type 1 or type 2? So there are other names. Type 1, type 2 is one of the names.
Type 2 is hosted.
Type 2 is a hosted, yes. Yeah, other students, how about Gautam? Yeah. Any other name for type 1? Just hold on. We came together. You can take a look at the note. Here's a hint. So type 1, what's the other name? Can you? Bare metal, native, right? Yeah. So we talked about the server virtualization types. The virtualization. Previously we talked about how is the traditional server, then virtual server, and what are the benefits of having virtual servers. And then there are also different ways of implementing virtualization, and there we talked about type 1 and type 2, right? Just recall that the virtualization is the engine of the cloud computing, but it's not only for cloud computing. It can be used for many different purposes. Server, client consolidation, testing, development, high availability, fault tolerance. Okay, so let's go on from here. Any questions? I hope, by the way, the assignment 2 was due yesterday, right? I hope it went well. I didn't hear, I asked a question, maybe I will double check with him. Not many students showed up on the office hour for the TA, so means not much students you have encountered. I would interpret that way, or I don't know. Yeah, so it's just the it can be actually not doing the work, right? I hope that's not the case. Okay, so hope that assignment 2 went fine and enjoyed it. This is the first level. You use by the way, the tutorial that we have given, it's just one of the ways. There are many different ways. You can use any clouds, any public clouds too. So just get your hands dirty, more than one, up to at least the 3. That's what I'm asking you to do. So yes, it's a kind of should we give it the important skill is a troubleshooting. You find a problem and solve it on your own, but not giving any guideline could be a lot of many students may have trouble. So if I give a guideline, everybody just follows. Still, it's a good practice, but you can do more than that. That's what I'm saying.
I face one of the problem in GCP. So the problem is my server was working, But the thing is, if we want to know, if we want to use the load balancer, we need
Oh, are you the one who asked that?
yeah.
Load balancing, this is just one server, right? Yeah, so that's a load balancing. If that's a good, you know, the aspect to think about. Um, Figure it out. Yeah.
I didn't understand that part, why we need the load balancer, but my server was
Oh, so
working.
because there is I mean, server load balancer. The purpose is that balancing the loads across the multiple servers.
Okay.
Here you have just a one single server. It can cost you a lot.
Okay.
Just, right? If you use those things, you can have your own computer, own OpenStack, the virtualization implementation, and then you can have multiple servers. You can have your own scheduling. A lot of research is really about how to do the load balancing.
Okay.
Out of say 3 available, which one you want to distribute the load to. So that's a good optimization or different aspect approach you can take
Okay.
to do it better. That's more advanced thinking. That's really good. Yeah, that it can cost you. So don't blame me if you have to pay for that. So this assignment is really simple. Have a one serverless service server. Basically, on a remote system, we want to have a HTTP server up and running that can present static single HTML file.
But my server worked without the load balancer.
Yeah, that's fine. That you fulfill the requirement.
Yeah, and another thing we faced during the load balancer server is that we need certificate to something. I didn't understand what kind of.
Oh, so that might be to do with the security related one, I
Okay.
guess. Yeah. So
How we can get it? Like if we want to have that certificate, but
so there are vast kind of things available. The little details that you have to find it out. You can figure it out on your own. I can give you the bigger picture. All the details. It's really what all the CS assignment is about. Some of the very common errors. That's something you can post it in the Q&A FAQ, right? You can actually put it on the discussion board. Here's the problem approach I have tried, and this is the solution. Or you have just a question. That's you can also post it to have other students to answer the question. So assignment 2 was again single HTTP server. The presenting one single static HTML file. Later, the next assignment will be using virtual machines, still singles. Okay, let's go back to this server virtualization types. So we talked about the type 1, type 2. Type 1 is like number 1, going over the entire hardware. Everything is virtual machines are on top of hypervisor. Here's type 2. The first thing is an OS hypervisor. It's like one of the application programs. You do VirtualBox, it's like an application program, but in fact it's a hypervisor with a lot of different operating systems. I showed you different illustrations, right? So, like the paper from 74, Kopek and Goldberg, they had hardware inside, the VMM outside the virtual machine. That's a different way of the visualizing abstract concept. And this is more modern, recent illustrations, but when you have your own architecture in your industry or academia and research, the most of paper actually starts a lot, not all the paper, system-related paper start with the system architecture. Here's a big picture. So I want you to be familiar with the different types of illustrations and be able to have your own illustrations as well. It should make sense. It's so suppose if this is reversed, that's wrong, right? Server virtualization, we talk about the type 1, type 2, but people also talk about these things. Hosted virtualization, OS level virtualization, type 2. Full virtualization, it is in the context of type 1. Hardware, either type 1 or type 2. Para virtualization in the context of type 1 virtualization. So EXX, VMware, this is the model used by this one supports full virtualization. Hardware support is it's regardless of the software side, but knowing the hardware support for virtualization, the hypervisor can be more efficient in implementing virtualization. So we have a quiz, and I'm not asking you to memorize a lot of things, but still some of these things I want you to memorize and be able to tell, oh, that's a full virtualization. So you can ask like UMKC data center, what's the virtualization we use, VMware, which one, PSXi, PSX, things like that. Para virtualization, it's the model used by Zen. Zen, remember, University of Cambridge, 2003 paper, they made it open source, and bought by Citrix and other companies later on. So let's go a little more illustration, a little deeper. OS level hosted type 2 virtualization. Here, virtualization capability is a part of OS host, the host OS. So here is a host OS, and virtualization layer, what it means that this is a VMM, this is a hypervisor. Application will be running on top of the OS just like other regular thing, but if we have a hypervisor type 2 OS level virtualization, then you can have all these things. You can install and run as an application. So you might want to try I don't force you to do it as an assignment, but still all of you, I want you to try installing, running, VirtualBox, virtual PC, and then you will know how much it will require, how much memory storage you want to allocate for this, and some of the parameters it is asking, and Linux is an important part. Linux is the really cluster OS, in other words, cloud OS. You don't use Windows desktop or Mac iOS for cloud, right? Remember, there are different ways of accessing cloud. WebClick, that's really high-level user, but for real developer, serious folks will access it with the CLI, command line interface, and that's all Linux. So a way for you to practice, play around with Linux on your Windows, Mac OS is using virtual PC, right? So try that out. Full virtualization, not really starting, it's not just one paper, but around the time, Disco paper 95 from Stanford, where the one that had started VMware. Actually, this picture you have seen, you can see that this picture is similar to this one, coming from the same, either author or industry. In fact, these are from the VMware. So VMware, when they started the virtualization, it was really full virtualization that makes this one really thin, make the performance good enough, and enables fault tolerance. So here, look at this word. It's a lean virtualization-centric kernel. Like the Linux, there is a kernel, core functionality of operating system, and then there are shell and other system libraries. So this software layer is supposed to be thin, In other words, not heavy, thick, taking a lot of memory, a lot of computation. It shouldn't use the CPU a lot to do the translation from application to the hardware. So it's supposed to be lean virtualization centric kernel, really core functionality only. Remember, even the 74 paper said that the efficient isolation of a machine, right? So efficiency is important when we say virtualization. You can do it, but it's so slow. Nobody's gonna use it. So that's a lean virtualization layer. And then there's a service console for agent helper applications. There will be some software to, like the management, the program, in other words, console for helping these applications. Its functionality is basic functionality provided is the all of the hardware I/O devices, CPU, memory, network interface card, disk, and maybe printer or any I/O devices that are connected to should be exposed to virtual machines. Virtual machine, you should be able to, the programs on the virtual machine should be able to do the printing, do network activity, use memory, of course, and so on. And then here, full virtualization is different from para-virtualization in the sense that it allows unmodified guest OS. So this is the original traditional one. Later it comes para-virtualization that requires the guest OS to be modified. Modifying, you have to modify the guest OS. That's a overhead. I mean, it's not it's you. If you have an option you want to use as the original guest OS, right? So why would you bother to have to modify the guest OS for virtualization? It's because performance issues. So full virtualization, they say it's lean, still the performance was not good enough, and para-virtualization made it better. So that's what the explanation is given in the context, because we know what's coming later. That was a para-virtualization. It requires modified guess for performance improvement. Now, in comparison, full virtualization will cause some performance degradation. This management software is a service console. This is another illustration of type 1 virtualization. This is an IBM, so this is a VMware, this is an IBM hardware outside. So it's completely the opposite of the original 94 paper, right? The hardware outside, inside the operating, no, let's say hardware, and then this is a enclosure, so it's not opposite, let me say. Enclosure is the hardware, inside there's the operating system, and on top of or around, based on the core operating system, there are apps. So this is a different illustration. User domain, unit, that's the term. Para-virtualization is where you have to modify the guest OS to cooperate with the VMware. So this picture is from VMware, right? You can tell. So they provide the virtual hardware abstraction that is similar but not identical to the real hardware. It gives a better performance. So that's the idea. OS is not native guest OS, but para-virtualized OS. So what it means is that in the application program, you have a system codes like I/O devices. or network interface. It's really access to the hardware. Those system calls, it has to be specially handled so that the other program will not interfere. The printing, as I gave many examples multiple times, right? One application printing, you don't want to you don't want that printing to be intervened by other application, right? It has to be really the original page that you want it to print out. So that means that the printer driver or the software that handles the hardware is in control. You stay in the queue. I am handling this. Okay, so that the translation has to be done, and the para-virtualization, whenever the I/O system call is done, that is called the system call in the lower level. It's aware. Oh, this is a special treatment applicated one. It's not just a 1+1 or A+B arithmetic CPU computation that can be done whenever time slot it gets. Okay, so any system call, this is a special treatment, the function. Please handle it differently, especially. That's what this para-virtualizer OS has to do. So you have an application development, application program built. You make an exe file or the execution file, right? That is actually working with the OS, and OS handles like a driver and also all those I/O access. And that OS, they has to specifically know this is a special operation for an application. So that's how the system call. I think I have the example more later. System call, like the things are abstracted. So file open, just like a file open, can be printer open. But rather than that, this is a special, file open too is a disk access. Have to be the isolated, but the I/O devices is more difficult to isolate, and that's what OS will do. Okay, so we talked about the virtualization, how it's different from simulation, right? Simulation is where things can be simplified, the hiding a lot of details or abstracted. The details are abstracted out, whether simulation or anything. In the research, if you use real data, it's valued better. If you use a simulation, unless you have no other way of doing it, it's valued less in comparison with the research work that uses real data. So that means that simulation, it has a limitation in terms of the control variables or environments you considered into account. So that's a big difference between simulation and virtualization. Virtualization is where there is an isomorphic mapping between guest and the host real system, right? So that's virtualization, but still it's a software, right? How do you implement it? The emulation could be a way to implement the virtualization. So virtualization is an isomorphic mapping between virtual and physical, and that can be done with the emulation techniques. So this is a technique or a process of implementing some functionality of one system on another system that can have a different interface and functionality. So the good example, so the simulation can be a way to implement the virtualization. Different emulation techniques can be used across the different platforms for compatibility and so on. So we have different CPUs, Intel, ARM, AMD, those CPUs come with a special hardware architecture instruction set like x86, CISC architecture, complex instruction set chip. I think so, right? CISC architecture, you probably have heard of it from our network. Computer architecture course from maybe sophomore class. So the x86, you have heard of it, right? x86, 8086, that's the initial one. That was my first computer. And then we call it XT, and then 386, 286, 386, 486, 586. Those we used to call it 80, no, 80, 386, 80. Are you following the number? Yeah, no. 486. That's how old I am. So that's a CPU. The CPU generation, and even all the current Windows, it's based on Intel inside. That's the x86 based. Apple M1, M2, it's a different one. But so here's a different those instruction set, meaning assembly language, right? Machine language. But human readable form will be assembly language. So there's an instruction set, and then on top of that there's an operating system. On top of that, application, you make an exe file. The exe file running on a machine, OS will translate it into the machine instruction, right? So that's how it is done. And virtualization, actually implementation, has to do all these translations. But before we look at the translation, what are the different ways? They always design goals first. So you want to be able to see the big picture forest as well as later trees and the branches. So even portable design, any the technology design, we first think about the goal, and then how to get there. The goal can be what could be the goals of virtualization when you try to implement it. And these are some of the important components: protection, illusion, performance. Performance, we want to do what it's supposed to do well, right? And also protection, it's really about the virtual machines. They have to be isolated from each other, should not interfere with each other in terms of operations, so it has to be protection. And for users, they shouldn't feel this virtualization running on below. That's the illusion. So a little more detail. Protection means that virtual machine, the one on the top above the virtualization, so the virtual machines must not change the state of the VMM directly. So it's really the protection from each other, and also the protection between the virtual machine and the virtual machine monitor hypervisor. So they should be able to interact with the hardware, but still go through the VMM, but not change the VMM. They should not change the state of the other VMs. So protection between VMs, the protection against the other VMs, protection against the VMM. That's what it has to do. Still be able to interact with the hardware. Virtual machines must not be able to change anything outside of the virtual machine. Okay. So to make all these things happen, you keep your boundary. That's the protection. Illusion means that virtual machines, which is on top of virtualization layer, VMM, must not be able to determine what is running, that it is running on a virtualization environment. Okay, so the illusion like it is native. You can see that the para-virtualization violates this um, this goal. So all these goals or desirable the objectives. First of all, it's a good thing to have, and it's all making good sense. But also, as a critical person, student who likes to break the rule, you also want to have the different aspect as well. Well, what about if we bend a little bit this, we can do these things a lot better. That's a good idea. In fact, many years ago, my master's the thesis was too many years ago, more than 20 years ago. So it was about the human character recognition, and everybody was working on how to make your algorithm better to understand the human character better. And then I felt, that was just before the winter of the AI, right? The second winter of the AI. It just didn't work well. So my approach was completely, how about if we human write in a specific way so that machine can understand it better? Okay, so that was the approach. And maybe some people didn't value it much, but many years later there was a PDA. Before we have a smartphone, before we had a feature phone, there was a PDA, personal, what does it stand for? Device assistant, like in a small pocket, small assistant device where you write notes and
Diary
things.
assistant.
Yeah. What's that?
Personal diary or something.
What's that?
Diary.
Diary. Well, we use it for writing notes, appointments, the phone numbers and so on. Anyway, so address book, those things, and they use it really. I did it for a Korean case. They use write A like this, right, and 7 in a special way. So they make it's not too difficult. Of course, there has been a lot of studies before they do it. I guess the making human a little bit I wouldn't say inconvenient, but change a little bit of habit and you can improve the recognition rate a lot. So that was the thing I was really surprised and pleasantly surprised to see that. And illusion is the para-virtualization really bends the rule a little bit and make the performance really better. But for now, before we talk about the para-virtualization, illusion is a good thing to have. It makes a good sense, right? Well, virtualization, you take care of all the complicated one and let the virtual machine be themselves, not aware, doesn't have to be aware of it is virtualization environment. Because it's important for all the software that is being built, right? If you have to change everything all above, then it becomes a closed source, closed community. It only works for this platform, this virtual machine, the OS version. So it has a good reason why the illusion is a good thing to have. And then performance, of course, if it doesn't work, it won't be used. It's easy to say, hard to implement. It doesn't say performance should be better than, the overhead should be smaller than 5%, things like that. Just the better, the better, right? So that's the performance, the requirement. We see a lot of things that, like the peer-to-peer system, first generation peer-to-peer system, centralized, there's an Napster, there's a decentralized directory. It had all kinds of issues of the copyright system. So the second generation peer-to-peer system is completely distributed, Nutella-like system, we call it. So everything is decentralized. Then it took so much time to find the content. So in other words, it didn't work well. You want to find some, the open file content, and it takes forever. So performance sucked. People didn't use it, but actually it was really it was beneficial, at least to some academic purpose. And I actually had it use it for network architecture class, and it was an inspiration for the third generation P2P system, which is a hybrid. Like a lot of technology advances, somebody have an idea, and then it has limitations are found. People go the other way, and then this doesn't work well. So the next one is hybrid, right? It happens a lot. But they started coming. The performance, second generation P2P system, it was cool. Performance wasn't good, so nobody used it. For virtualization, in fact, it's not that we didn't have a good virtualization. It's not that we didn't have a virtualization idea, but the performance was not good. But only the late 90s, Disco Paper, VMware, they made the performance really good, so it's usable. We can commercialize it, and then it became bigger and bigger. So these are the implementation techniques for full and para virtualization. By the way, I have a quiz today that includes this example. It's an open note, you can take a look, but I'm telling you what's the question. So the full virtualization can be implemented by pure emulation, drop-in emulation, binary translation. These are the different approaches. Para virtualization is basically some of the issues you have to do here. You don't have to do it because OS explicitly tells that, modified explicitly tells that. So emulation is a way to implement the full virtualization. There's a problem. So it does trap in and emulate is the next one. It does require hardware assistance. So binary translation is something similar to this without requiring hardware assistance. So you see that VMware started with this, but it does everything these days. First of all, how to implement the virtual machine? Excuse me. I'm almost far enough. No COVID. So here, the first step is the NECS student. How many of you have taken compiler course? No one? No compiler course. Do you know what compiler is about? Right? Compiler is the system software that translates the application into a binary code. We used to develop compiler, and I don't think we used to offer compiler course, but not these days. That's unfortunate. So anyone who have taken compiler course will know, like can understand the concept easily. So the CPU will have to translate there's a system software have to translate it so that the CPU can understand CPU, Intel, ARM in those chips. So the Intel instructions, the computer architecture course, there's the instruction code, instruction like addition, XOR, move, right? The first there's a program counter. So here's a program flow. Here's a particular program counter. It's in executing certain instruction, and then the instruction will be either these of one of these. These are just some examples, more than that. So it has to figure out which one is the instruction and what's the computation is about. So here's the assembly code, the example. Adding long register to registers. So this is the, say, x86 instruction, maybe coming from different, the OS. You can emulate it in the C code, C++ code in a high-level language in the software. So this is an enumeration of all the, say, registers. So these are the register names. Each CPU will have the set of registers. It will have a specific, register size of 64-bit, 32-bit, and then this is adding long. So this is adding two registers together. This one line of the instruction can be emulated into. So what if into with this software, with this high-level programming, whatever the instruction might be, so you can have any set of registers defined by the CPU. And then do any computation like what the CPU will allow. So CISC is actually, it's a complex more. RISC, you might have heard of, RISC. CISC, CISC. Those are different computer architectures. Some has a more instruction set, some has less. Anyway, you can do the translation in a high-level language. That's what the emulation is about. But it is done at the really lower level. Right? That's a pure emulation. So it works. That's how you can do the translation, right? What do you think? What are the cons and pros? Good thing, it works. So, right? Most of the times. Okay? It's also simple in terms of concept, or you can get it done. It's slow. It's a lot of O in between. It's so slow, so slow. In other words, you cannot commercialize it. There is an example, real implementation called Box. Why somebody will bother to do this?
Is it just slow because it's not customizable?
It's not customizable. It's slow because of it's done purely in high-level language.
Right.
Software.
Just purely in software.
Purely in software high-level language, and it's the every even I/O instruction. So here performance. Every even I/O instruction, it will be all pulled by a centralized software and can handle it one by one. And then this one also has to translate it into the real machine it is running. But somebody bothered to implement it, and it's the first of all proof of concept for research. This can be done, right? But this can be also very useful. For what? For for education, for classes, right? If you take, how many of you have taken up? I believe operating system is. I don't want to even want to, they ask you to raise a hand because I'm afraid to see some not able to that. You should take the operating system, right? It's a prerequisite. If you are not, if you are rusty or didn't, pick it up. Okay, so operating system typical project is really not typical these days. These days, the students are a lot more. The older students, if they used to do it in a hard way. These students are all spoiled by Python, and then all high level languages don't want to do a system level. Then your job can be easily replaced. Okay, you dare to go lower. Anyway, the building a small operating system is a typical in my time. The project in the OS courses, and then you could use this one. Okay. It's so slow. How can you do? Whenever you think of the performance issue, hardware, any talk you hear, this is a good algorithm, and we can make it in a hardware. That means faster, right? All the AI machine vector computation is so slow. If you use a GPU, if you use an FPGA, it's faster, right? The blockchain the computation, the mining too. So having it done in hardware can make things a lot faster. So these hardware vendors are realizing it and support it in the hardware. What it means is that they make an extension to x86, for virtualization. It doesn't really replace the virtualization. It doesn't do all the things in the hardware. What it does is that key feature is that some problem instruction, it will trap it and do it in the hardware. So trap and emulate is what the hardware, based on the hardware assisted virtualization. So what is the problem instruction? Or what are the problem instructions? Those are the I/O instructions. Okay. So here's the trap and emulate. We want to do it faster. So these things actually it can be okay. Just adding, the ALU or the CPU only one. But the operations like this, it requires special hypervisor intervention because this is an interrupt. The INT is an interrupt, and then move something to special register and do a I/O. So send something to a printer, send something to the network card. So this one does require hypervisor. It's the intervention, and it's important for you for the hypervisor to know that whether this does require the hardware assistance or not. So whenever the I/O instruction happens, I/O is just some example, most example, but there can be something else as well. So for I/O instructions, CPU, what can I say? The hypervisor will trap it and send it to the hardware virtualization support and make it they handle it there. So that's that's what the trap and emulate is. So pure emulation, entire software. the next step is a trap and emulate. It uses the emulation most of the time, but for special instructions or problem instructions or I/O instructions, it will be trapped, interrupted by the hardware, and hardware will take care of, you know, this they provide an isolation across the virtual machines. So that's what the approach is about. So it gives a big performance benefit, but it's a little harder to implement. And in fact, it was introduced after the hardware support. So the so-called problem instruction or sensitive instruction that causes the hardware and then made dependent by the hardware. Actually, there is a little bit of trickiness in the implementation, in a sense that you cannot just say interrupt this number will be I/O in the I/O access. You know that there are so many different ways of doing the same thing in a software. The causing the interrupt handler can be many different things. So like popping the flag can be used for clearing interrupt flags. So different ways of doing the same thing can happen. You cannot determine this is the I/O instruction in advance by looking at the code. If you have just the most of the code, you might say, you know, this is a print in a hardware printing, but well, there are many different ways of doing it. You know, you call this write to a printer device. You can do that too. So all this the tweaking is involved if you do it in the software side, but hardware can make it simpler. KVM is the full virtualization that uses trap and emulate. And then the next one is that what if we don't have anything, any hardware support? Can we still have can we do better than pure emulation? In fact, that's the original VMware. So then after this, the Intel, AMD, they supported virtualization, and trap and emulate was possible. So binary translation, what it is that just-in-time decompilation. You probably have heard of that. So from an exe code, you don't know in advance because some of the conditions might need differently depending on the operation while running it. So just before the I/O access, we will find out this is the I/O access and call it, do a special system call for I/O access. And that's a special system call will be called hypercall. System call, but the special system call for the invoked by the hypervisor. That's what it means. So this is here it involves the detailed explanation involves with the x86 the instruction sets. But for you, I would say just know that there are different ways of implementing virtualizations, pure trap and emulate, and binary translation. Trap and emulate does require hardware assistance. Binary translation is a dynamic translation rather than using the exe code as a static one. Just before the execution, once it finds out the I/O access, it will translate the regular system call into a hypercall, special system call. So that's what it does. And these are the examples. Okay. by the way, the Hyper-V is the one that's used by Microsoft. VMware can move these as an example. So, and then now let's talk about the Terra virtualization. As we talked about many times, the tricky, the most difficult part of doing the translation, doing the virtualization is about the special system call. I'm just giving the major example of I/O access. So I/O access, how do they handle this I/O access to provide the protection isolation, right, across the virtual machines? And Terra virtualization, well, what about the guest OS will explicitly handle this one by knowing this is running on top of the virtualization. So that's what it is. It allows guests to voluntarily trap into a hypervisor. So previously, thanks to the hardware support, Intel V does the trapping. Or binary translation, just-in-time translation, it knows that, oh, this is the I/O access just before the running, right? And then do a trapping. So that's how it does. But now, well, why don't you tell it in advance? If the guest OS knows that this is running on top of virtualization. Right? So that means that, and then all the hardware access system call will be hypercode. The system call can be many different things, but it can be just writing on the interrupt. But the I/O access is a definitely part of the system call, and it will be called the hypercall. Then no special decoding is necessary. So the Terra virtualization, it means that the hardware I/O doing another level of abstraction. Abstraction is the word that we use a lot in virtualization. Hardware is abstracted. File, the disk is abstracted. File system, it abstracts the storage system, right? So it is the really key. In fact, that's a power of the computer science. We do divide and conquer, abstraction, parallelism, pattern matching. So this is what we do well a lot. We do a lot, and you see example in the virtualization as well. Hardware is another level of the virtualization. The abstraction is done for improving the performance of virtualization. That means that guest OS has to change a little bit. All the components changed into the hypercall, and it really depends on the hardware platform. So its performance is a big plus, definitely, and it doesn't require Intel V, right? But guest OS has to be modified. So some guest OS that is not modified. Guest OS modified means that you should use a special version. I mean, a regular user won't modify the OS itself, right? So only special version, only the OS versions or OS types that are version and types really ported for Terra virtualization can be used, not any guest OS. Zen was the first one. Nowadays, later VMware does it too. So VMware does all kinds of virtualization, right? Type 1, type 2, different levels of type 1, 2. what do you think? Let me say, let me ask you a question. So, GCP, do they use para-virtualization or full virtualization? If you use GCP, if you use a VM service, is it type 1 or type 2? When you use a VM, later if you do assignment 3, then you will use a VM, then you will be asked to choose an operating system, right? Linux, Windows, and then that Windows operating system will be on your virtual machine. But if you are public, in other words, if you are public cloud provider, are you gonna use a type 1 or type 2 virtualization? This is a simple question, right?
Type 2.
If you use a regular, you as a public cloud provider, if you are the Google GCP provider,
Type 1 because it runs on the servers.
Type 1 because?
It runs on the servers of Google.
Right, yeah. Why not type 2?
Because it's slow.
Yeah, of course. So performance is the main thing, right? For a commercial product, it has to work well. It has to be slow. Therefore, they use, of course, type 1, right? What do you think? Do they use a full or para-virtualization? Full virtualization, they do. How about para-virtualization? They also do.
They just use full virtualization.
They can use para-virtualization too. The performance. That's what the provider aspect, right? It has to work well before it provides a hilarious, nice service, AI, things like that. First of all, basic things has to perform well from a public provider's perspective. Therefore, they use a type 1, and type 2 is useful for educational purpose, for lightweight, users like you. You want to just try things out on top of your all other personal activities running on your laptop, right? You are using all the email and all kinds of other activities doing on your laptop, and you want to also use Linux for practice, for educational purpose, or just maybe simple development, type 2. Any serious one will be type 1 for performance reasons. And for Google Cloud Provider, I gave you a hint. When you click on VM, they will ask you which OS you're gonna use, and they already have some versions predetermined. They are not really giving arbitrary random one, in fact, because it can cause all kinds of problems. Users will scream. They test it, and they already that's an opportunity for them to modify the OS. They can modify the OS, right? Therefore, I said the OS has to be modified, not the applications has to be modified. Therefore, it makes good sense for them to use para-virtualization, right? So they use it either or both, para and full virtualization, with hardware support. Of course, hardware support is available, so it's not the dynamic translation. It's a trap and emulate or para-virtualization. So, yeah, I didn't say that explicitly on the slide, but if I ask you in the quiz, you should. That's not a difficult thinking to do, right? So let me stop it here. Let's do a quiz. Open book. We don't have it. Open note. So quiz access code is week 5. Oh, I have just one slide left. This is a small, this is the access code.
Canvas is not.
The Wi-Fi
Yeah.
is not good.
Canvas is not working.
Yeah.
Canvas is down.
Yeah.
Not the quiz. Canvas is Canvas the UM system. What do you mean by Canvas is down? Okay.
Error.
It's a well, I'm just trying to see, is it AWS issue or Canvas issue? So I will let you take it by the midnight today. You have the access code, right?
Can you?
Yeah, I do. This is access code. Let me see. You're not supposed to share the access code to other students. I'm counting how many students are.
This is the access code.
Yeah.
Week 5.
Week 5-1.
-1.
So let me just let's finish this slide then. Remember the virtualization thing at the plateau of construction. It's a these are the things that managing the managing or the build improving the virtualization. It has to do all of these kinds. Load balancing across the VMs. Load balancing is always again about what? If you have a web server and suppose you are purchasing 10 servers for your web service, you want to balance it so the performance will be good. That's an application-specific load balancing. And here, what I'm talking about is the load balancing across the virtual machines users. So all of these are issues, meaning that when you read a virtualization paper or compare virtualization, hypervisor, Hyper-V versus Camel, VMware ESX versus Zen, right? You want to see which one is better. You have to have some metrics to compare. Is it easy? Does it well utilize the hardware? The interoperability, load balancing, security protection, energy saving, is it all good? For a virtualization technique to be working, fault isolation, fault resilience, it's easier to say is that we provide a failure isolation, failure resistance. If somebody says so, it's almost like we provide the security. Security is a broad, big umbrella. There can be a lot of different services, and also there are always new attacks, and it's open field. Failure isolation, they might have a well-known failure protection, isolation, and mitigation strategy, but there can be some more as well always as it runs. So it's not really binary. It does provide or doesn't provide. So most of things are, it's not really binary. Energy saving, we provide. It's not about, we provide, the energy saving through this mechanism, and by experiment we show that under this working in the workload, it can provide energy saving by how much. You want to be more specific. You want to hear more specific the performance statement. So virtualization, I said it's mostly the solved in terms of it provides protection, illusion, what's the other one? Performance, right? Performance is good enough, but all of those you can improve, and more things can be further improved. Okay, so let me stop here today, and again, please will be available by midnight today. Hopefully, Canvas will be up for. Well, then you have to keep checking. Canvas is up. Let's say by tomorrow. Okay, I don't want you keep checking the Canvas. Okay. It's not that anyone here made it, right? No attacker inside the classroom. Hopefully not.